So this is a job I get in probably about every month or so, maybe 2 months from the patrol wreck around the corner. Now a lot of mechanics will tell you to put a brand new manifold on, and one of the guys there, just on YouTube I was watching, said that they cooked it in a pottery oven to 600 degrees, which is a form of stress relief, but there seems to be a misunderstanding of what's actually going on with these manifolds. So there's a pile there that have been machined. This one I've got to take a final cut on. It's a little bit of corrosion at the far edges. Basically, every time these go through high heat cycles, this cast iron is contracting. And because you've got more surface area here at the back and you've got open ports, the underside of this is contracting much more per heat cycle than this is. So it forces it convex. Basically, it's like a constant pulling force, and all this cast iron down the bottom and even these areas up here are in compression. If it's really bad, you can actually straighten these through peening. So if you set this up on an anvil and you have to grind up a peening punch to the correct form, you can peen through the ports there and you crush that back material, and as you squish it, imagine it's like Play-Doh, it forces it back up. So you go from convex to flat or even to concave. On some of the old 40s and 50s era manifolds, I'll actually do that before I machine them so I can take the minimum amount off. This jig I've actually designed here is a 3-point jig so I can do the minimum amount of material to get perfect cleanup. It's a 3-point jig. I actually took a brand new manifold, like a factory manifold that Buddy provided me, welded this all up. It's got basically 3 points on the bottom, it's relieved on the side with 2 points there. And with it all fabricated, I flipped up a new manifold, clamped it up, and I machined those 3 points. And now this jig gives me the perfect factory geometry. But if I want, because there's a few manifolds there that are very different casting runs, I can shim 1 point there to bring it up that way, or I can shim either of those points to change the tip there. From the contraction that goes on, it always pulls a little bit that way. So you end up taking a little bit more out, but we're talking a few thou here. Each one of these, the least bad one was about 25 thou, and the worst one, I think probably third one up there, was 42 or 43 thou off until cleanup. But now, because these have gone through all those heat cycles, the material here is, everything's already in compression, these don't warp. So Buddy around the corner, who drops all these off for me, he's a wrecker. They get an insane amount of motors in. They're actually really good to deal with for spare parts. They do new and second hand. He's actually pulled the motor off, and it was one of the first ones I machined, or very early, so it had been on there for quite a while. And so he must have sold to someone, and then the motor's come in because the car's been wrecked. It was a little bit filthy, bit of gasket goo around it, but I cleaned it up and I checked it, and it was pretty much in the identical state to when I machined it. I said, it's not worth machining this again, just take it back, put it on one of the shop cars, the personal cars. It's not worth the cost. And as to cost, because he provides me so many, I usually do these for 60 bucks per manifold. When I get people off the street dropping these in, I usually charge more because I'm setting up the jig, and with all the cast iron dust and the cleanup, it's not really worth it as much for me. But just to the comments online about putting a brand new manifold on or even baking that manifold, when you put that through the heat cycle, you are relieving stresses, but that manifold you've just baked is going to end up very slightly convex. You'll also talk to people who will say to use Inconel studs, which there's nothing wrong with that, but those studs will eventually rip out. You're basically just forcing this to conform to the block, where you don't want those stresses there. And apparently, again, I'm not a patrol guy, I'm just a machinist and a machinery builder. When these start warping, they whistle quite badly because of laminated gaskets. Anyway, that's just my 2 cents on these ZD30 manifolds. You can put a comment or anything if you don't think this is the case. I'm always open to opinions. And another little trick with some of these manifolds before I go, you get thermal stratification when you're machining these, in that if when it's quite cold, when this heats up, it will actually expand the top and you will get very slightly convex. So you can play that to your advantage, where if you know a manifold is still quite fresh and hasn't warped much, you can actually get the oxy torch and spot heat these sections, or run a blunt cutter for a few passes, and basically you'll machine it in a state where it's being force convex, and when it contracts it'll go concave, and then when you have the next heat cycles coming through, it will go onto parity before it goes convex. And as all good automotive machinists know, you always tip your head over to generate a concave surface. That